Today's job is to redraw a figure for a manuscript. So the revisions, the review specified, it's talking about this figure here. Now this is a phylogeny which shows trait data plotted on the terminal loads of the phylogeny. And if we look at these closely, the reviewer specifically stated we have the known state as a black border. So this is where that species for this particular trait is known in the analysis, and we have a predicted state with a grey border. That is where there's a computational analysis to try and predict what the state is based on the model of trait evolution. Now the review stated black and grey margins are difficult to differentiate, and instead better just use a different symbol, which is a good idea. So this is, I think we can just plot triangles for one of these. Now where you have a predicted state, this is a pie chart. Still need to zoom in a bit closer. A pie chart, this is going to be awkward to plot this as a different symbol, so I think we would plot the known state, which is a solid colour. We can plot this as a different symbol. So I'll plot this as a triangle. Now when I originally did this I plotted a larger phylogeny. I transferred this to PowerPoint or something and just cut out a segment and printed this as a JPEG or something. Now this is not really a good way to do this. After you've gone through the initial review stage, you need to be printing high quality images, so all this needs to be printed at once during, I'll do this in R. So effectively this means I need to plot a two-panel image, two-panel window, and I need to plot the exact positions. Now I've done this already. I didn't bother recording this because it's a bit rather laborious. It took me a while because there are lots of things which need to be, lots of parameters need to be determined. Exactly what is the plotting window, X left, X Y, X left, X right, Y upper and Y lower. This is the plotting window. Also the dimensions of the phylogeny, scaling factors along the root to tip axis need to be exactly right to make it look, to maximize the visual information, and also just to make it look nice. Terminal sizes, exactly which segment of is being plotted, and various other things. So it's a gradual process of tweaking each of these. And, we tweak one thing and then it messes up something else. So it's an iterative process. But this is now done. This is exactly what I think is quite nice. But this will be two panels, so there'll be another phylogeny on the right hand side showing a different trait. I don't need to worry about that now. But so for this point, this is plotted to everything on a single PDF. So this will maintain the quality. You can zoom in very high and it will maintain quality here, which is exactly what we want for a high quality image. And you can see these pie charts. So what I need to do, anything with a black border, this needs to be a different plotting, needs to be a different point type. So I need to just get the R command to do this. I need to differentiate this in the code. So that's the main job, and then need to incorporate the second image and incorporate a key in a wherever there's any space in the image to show what these are, and then that will be done then. The first job is to just get the command for printing triangles instead of circles for the known states. And I found a position this will be need to make this adjustment. So here, go back up, we are there's a lot of code just for in a single node, and various things. At this point it's in a single node of the phylogeny and doing rather a lot of different things. But one thing it's doing is making various decisions about plotting. And here we are. This script again, which does a lot of the different things it uses for plotting. And here it's making decisions about plotting these points at the terminals, and this will be the pie chart. So if this hash here has in it the stored, which are the known states, and which are the predicted states. So the predicted states will stay as a pie chart, and the known states, this needs to be adjusted. So we'll have a new setting whether or not to draw as retain the old style or to draw as a triangle instead. So we'll come back to here in a moment, and we'll have a go up to the main we'll have a new option to change the point type here. So if known states equal 1, we'll draw the circle as previously. therefore if we set it at 2, then we'll draw a triangle. And here we need to insert the command for drawing points as triangle, which I don't know at this point. I know that we will use a points command. And we need to I think it's PCH which determines the point type. I'll just check. So normally we have 16 plotting symbol 16, which is a filled circle. So we need to use in 17 a filled triangle. So there's a simple way to have a symbol with a border. I'll simply print the same thing twice, a larger one and a smaller one. Larger one being the border, and then the smaller one over it. 17, okay. Although this is Perl command, Perl code, we are writing commands for R. So this is our format command is draw a circle. So we have the X and Y positions we are plotting at. So this is draw a circle, which is a bit of a actually draw a pie chart. I don't know if the CEX convention is equivalent, so I'll specify independently the CEX for a triangle. And we need a plot color. So I'll have two CX, X's, one for the border and one for the fill. And we'll write this into a single variable. And this is local to this conditional, so we need to put this immediately after. Okay, so set the variable, local variable equals, and then a single string within which is the R command, concatenate character. So we'll add to this a second string which has a second R command. First one has border size. Okay, so you need to think about the plot colours. Yeah, so first the border will be black, then the fill colour will be the corresponding to the colour assigned to a given trait or a given state of the trait under study. So all borders for the known states will be black. So now I think we just need to set the plotting size of these two items. I'll just make an initial guess. Border and fill. Yeah, okay, we didn't fail to change this. CX1 is the border, so it should be CX2 here. Okay, save and try again. Okay, so we have triangles printed for known states. Well, the obvious problem is these need to increase the point size clearly, but the second thing is, curiously, these are being plotted underneath, or if these being plotted before the branches, and the pie charts are not. So we need to think about the ordering of the commands. But first, let's so increase the size of the point. It's a bit odd that these are being printed in this order. So predicted states are being written to, okay, yeah, I see. Being written to this, appended to this variable. And the triangles we're printing to a different one, so I guess it's to do with the order of these. So I'll write these to the same variable, which is 4b. So I guess the branches, yeah, it depends what order the commands for drawing branches are appended to these. Anyway, we'll try this again. Okay, so it looks pretty good. We plotted a different. Let's look at this very closely. You can see the resolution is really good, even zoomed right into it. So this is why I want to plot these everything into this single PDF. So known states as triangle, as the reviewer suggested. So these can be easily discerned now. So I think it's not really now necessary to have the grey versus black border. So yeah, just needs tweaking now. I think triangles can be slightly smaller. What else? So I notice sometimes the predicted terminals are plotted above the known states. And sometimes the predicted terminals here is plotted beneath. So maybe this needs you to think about which one we want. I mean, yeah, I guess the predictions are more focused. The more the focal ones. I'm more interested in that because there's more information contained in these. So we'll probably just slightly reorder these. So these pie charts are printed after the known states, so they'll be shown more clearly. But otherwise, this is generally done now. Okay, so I'll say this is job done. I don't need to. I'll be printing another one on the right side, on the right panel to show different traits. So this is our body size, incidentally, and body size ITD, which is a proxy of body size using bees. So red ones very small bees. Blue. So these are a laser glossom. This is a type of quite small bees. And then the larger bees, green and yellow, which are not in this particular part of the tree. So I'll be plotting a second trait type. This is a sociality, which is of particular interest in bees. On the right panel. Okay, but generally that's job done for now.